Okay, this is 15.5, number 12. And while this is still a triple integral problem, we're actually going to have to set this one up. The question is to find the mass of a cube with a side length of 2 and a density equal to the square of the distance from an edge. So that's the tricky part. The side length of 2 is pretty easy. If we put one of its corners at the origin, then it's 2 in the x, 2 in the y, and 2 in the z. But this density is equal to the square of the distance from an edge. We're going to have to work that out. So what I'm going to do is imagine that this is the y-axis and the z-axis, and the x-axis is coming right out of the board at us. So that's the edge. The x-axis is the edge that I'm going to imagine is controlling the density. So we'll just place a point out in space, the distance between the origin, which represents the x-axis, and that point is at an address of y comma z. Its distance is d, and if we had to calculate it, then d will be equal to the square root of y squared plus z squared. And of course, they say it's the square of the distance, so I can get rid of that square root. So d squared is equal to y squared plus z squared. And that's also the density. So that's the density function. Okay, well, the rest of the cube, of course, is sitting at the origin, and it has limits of 2, 2, and 2. So it's 0 to 2, 0 to 2, and 0 to 2 of the density function, because we want the mass, and the mass is just the integral of the density. The density is only two-dimensional, so that's y squared plus z squared. And notice how we could have placed this along any edge, so it could have been x squared plus y squared plus z squared, or x squared plus z squared, and it wouldn't have mattered. All would have produced the same mass. Order of integration doesn't matter, so I can say dx, dy, dz, and then when I go ahead and perform all these, this one turns out to be equal to 64/3, and that is the mass of a cube whose density is equal to the square of the distance from an edge whose side length is 2.